Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad Iqmal bin Mohamad Zaiddie and my matrix ID is B09181021. And then I am from program BMH and my supervisor's name is Mr. T.S. Azwan bin Aziz. Okay, so I would like to present my final year project, which is the title is the application of waste heat from air conditioner for laundry drying. Okay, so here we have the content of slide. There are 8 in total, which is the first one is introduction, and then the second one is problem statements. The third one is objective of the study, scope of project, literature reviews, methodology, result, and the last one is conclusion and recommendation. Okay, so for the introduction section, we have the first one is drying cloth is one of the biggest sectors that consume a huge amount of electrical energy. Malaysians typically drying their clothes by naturally hanging their clothes under the sun, which is outdoor method. Okay, the third one is several commercial sectors such as hotels and hospitals use commercial drying machine for drying clothes. Nowadays, the laundry business is now growing significantly in Malaysia. The commercial drying and laundries in Malaysia use electricity, kerosene, and natural gas as energy sources. Okay, so for the problem statement, we have 4 points here. The first one is waste heat from air conditioner. Okay, so usually if the waste heat is not being used for any kind of activities, it is will affect to the global warming. Okay, so the second one is high cost to purchase dryer, and then the third one we have dryer is harmful for environment since the output is will release the CO2 carbon monoxide, and then the last one we have laundry dryer consume huge amount of electrical energy. Okay, so for the fifth slide here, we have objective of the project. In the objective, we have divided by two, the general objective and the specific objective. For the general objective, it is to design the laundry dryer that using waste heat from air conditioner. Specific objective, we have 2 points here. To determine the effectiveness of waste heat from air conditioner to dry the wet cloth or the laundry. And then the second point is to measure the temperature of the waste heat in the laundry dryer. Alright, so the next slide is the scope of the project. There are 2 scopes here. The first one is this project will focus on build a prototype laundry dryer to show the effectiveness of the waste heat to dry wet clothes without disturbing the air conditioner system. The second one, we have the project will show how the waste heat from the condensing unit of air conditioning system can dry the cloth. Alright, so for the literature review slide, we have 3 main literature review that related with my project, which is the first one we have waste heat, the second one here we have waste heat recovery, and then the third one is air conditioner condenser. Okay, so we are here in methodology. As we can see in this slide, and we have the flowchart for PSM1 and then continue to PSM2. Okay, so for the PSM1, we start with the idea and concept, and then my supervisor and I have discussed about the project title, and then proceed to the problem statement, objective, and scope, and then I make a research about literature review and proceed to methodology, and then do the project design and hardware integration, and then we will continue at the PSM2, which is fabricate the aluminium to build the cabinet, and then we go to testing and implementation. We take data for the result, and then we documentation and do reporting. Okay, so in this slide is about hardware implementation. And the first one is the aluminium plate with the thickness 3 mm. Why I choose aluminium plate is because it is reflect of the heat, which is it help my experiment to be more better. And then reverted tool to build the cabinet, and then I attach the heat insulation pad, which is to make the cabinet for the laundry drying process become more better, more effective. And then the dust screen is for prevent the debris from the fan of the condenser to go inside the laundry dryer cabinet. And then the last one, we have flexible aluminium ducting hose, where it used to make the waste heat from the condenser unit flow go through inside the laundry dryer cabinet. Okay, so we go to the measuring tool, which is I use two kind of measuring here. The first one is portable electronic scale, and then the second one is air quality with temperature and humidity sensor. Okay, so for the portable electronic scale is used to record the data for the cloth dry wet, and then after washing process, which is it will become heavier, and then after drying process, I need to see is there any difference on the wet process and after drying process. Okay, so for the air quality and air quality with temperature and humidity sensor is used to check is there any debris that go through from the condenser fan into the laundry dryer cabinet. And then the temperature is used to check the temperature of the waste heat from the condenser that transfer into the laundry dryer. Same goes with the humidity. If the when the cloth is wet, the humidity will increase, and then we need to check either when the temperature increase, the humidity will decrease or not. All this about is we'll discuss in the result section. Okay, so for this slide, I will present to you guys about the structural design. As we can see in this slide, there is the air conditioner room, and then the room air conditioner indoor unit, and then the outside we have the room air conditioner outdoor unit, and the waste heat will go through into the laundry dryer cabinet by using the flexible aluminium ducting hose. And then we have the T1. T1 here is referred to the air door detector with temperature and humidity sensor. Why I put the T1 here is because I need to check the temperature of the waste heat once it enter the laundry dryer cabinet. Okay, so here we are in the experimental setup section. Is the first picture here is where I built the laundry dryer cabinet by using the reverter tool, and then the second picture is once the laundry dryer cabinet is done, I attach the dust screen at the air inlet where the waste heat from the condenser will enter the laundry dryer cabinet. And then the third picture here is where I built the cone that will attach at the outdoor unit. The cone is designed where that will fit the condenser unit, so it can prevent the heat loss. And then the third one is where I attach the flexible aluminium ducting hose from the condenser unit to the laundry dryer cabinet. And then the second last picture here is the picture about air indoor quality with temperature and humidity sensor. This is for me to check the temperature and to check the ambient temperature and ambient humidity for the surrounding. And then the last picture here we have the portable electronic scale, where as I taught before, which is I take data for the dry wet, the after washing process, and then the after drying process. As for this slide, I will talk about the result. Okay, so there are three experiments that have been run before. The first experiment is run when it is on the hot weather. The experiment took 2 hours to dry the cloth, and then the second experiment is on the cloudy day, cloudy weather, which is took 3 hours for this experiment. And then the last experiment is experiment 3. It is run in raining weather, which is the time taken for the experimentary is 4 hours. So let me explain first about the first graph or first figure on the left side, which is for the experiment 1. Okay, so the blue line will represent the humidity for the experiment, and then the red line will represent the temperature. Okay, so for the first 20 minutes when the experiment was running, we can see here it is the value for the humidity and the temperature is constant. Okay, and then after 20 minutes, which is on the minute of 30, on the time of 30 minutes, the temperature will start increasing slowly, and then automatically the humidity will start decreasing. And for the experiment 1, the maximum temperature that I have been taken for the data is 38 degrees Celsius, and then the humidity dropped from 52 to 27% RH. We will proceed to the next graph, which is on the right side. The second graph on the right side is represent for experiment 2. Experiment 2 was run on the cloudy weather, and it took 3 hours for the clothes to dry. Okay, so as we can see here, from the starting when the experiment was running, the temperature will increase every 10 minutes, while the humidity will decrease for every 10 minutes. But in 110 minutes, the temperature in the laundry cabinet was dropped, which is from the 34 degree in 100 minutes to 33 degree in 110 minutes. This is because due to the cut off of condenser. Okay, so this is our last graph for result, which is will represent the experimentary. Experimentary was run on the cold weather, which is raining. So basically, the value for humidity is much greater than experiment 1 and experiment 2, which is the ambient humidity for experimentary is 64%, and then the ambient temperature for experiment 3 is 27 degrees Celsius. As we can see here, for the value humidity for experimentary, in the first 30 minutes, in the graph, we can see that it is constantly, and then for the temperature, it is slowly increasing. For this slide, I will talk about the conclusion for my experiment. The first point is the experiment was proof that the waste heat from the air conditioner could dry the wet clothes. And then the second point was the highest temperature taken for all experiment was 38 degrees Celsius, which is on experiment 3 and experiment 1. And then the third point here, we have the laundry dryer could be used for house such as condominium, flat or apartment, since they usually have the small multi-purpose storeroom to place the laundry dryer cabinet. And then the last point for conclusion is the application of waste heat from air conditioner for laundry dryer may help drying wet clothes in any kind of weather. Okay, so for this slide, I will talk about the recommendation that could be do for this project. The first one is redesign the air inlet at the cabinet on the middle to prevent a lot of heat loss happen. And the second point is installing a ventilation fan to improve the air circulation in the laundry dryer cabinet and help to pull up the warm temperature to go upward to make the drying process become more faster. And then the third point here, we have shortened the length of the ducting hose to reduce heat loss. And then the last one is use thermocouple to get better data for temperature and humidity. Thank you.